Okay, so we're going to be doing 3D figure applications where we're doing volume and surface area of three-dimensional figures. So I've got 4 examples here that go along with your homework. So for example 1, you've got determine the amount of water the aquarium below will hold. So this is the aquarium. I've already drawn the picture, and I'm not very good at drawing still. So this is the aquarium, and the water, this is supposed to represent the water, so it tells you this is 35 centimeters, this is 60 centimeters, and then the height of the water is 25 centimeters. So the aquarium would actually hold more than what we're going to calculate if you fill it up to the top, but you don't typically fill up aquariums all the way to the top, so we just want to go to the height of the water. So for this rectangular prism here, to do, if they're talking about the amount that something will hold, we're talking about the volume. If you're talking about how to cover something, then you'll be talking about surface area. But if we want to know how much something will hold, we're talking about the volume. So the volume of the rectangular prism is found by multiplying your length times your width times your height. So it doesn't matter if you call, which one you call length, which one you call width, and which one you call height. Length and width especially, most people call this one over here the height that goes up and down, but it really doesn't make any difference since you're multiplying. So we're going to do 60 times 35 times 25. If you do 60 times 35 times 25, you get 52,500, I think I have wrote down there. Let me just double check that real quick. I can't read my writing. Yeah, 52,500, and this would be in centimeters. And like for area, we do square centimeters or square inches or square feet. For volume, you do cubed, so centimeters cubed. So then the next question of this problem says, if the water level rises 2 centimeters when a fish is placed in the aquarium, what is the volume of the fish? So if we put a fish in the aquarium here, so I'm going to draw a fish, sort of. Wish I could draw better, but there's our fish. So there's our fish added to the aquarium. It says the water rises 2 centimeters when that fish is placed. So your water level, I don't have another colored pen, so I'm just going to draw it this way. Your water level goes up by 2 centimeters. So if this is 2 centimeters, that would mean this whole height then is 27 centimeters, because 25 plus 2 is 27. So there's a couple ways to do this. What we can do is we can find the volume of the water, so how much the tank will hold, using 27 as the height. So it's still length times width times height, so we would have 60, because that didn't change, times 35, that did not change, times the new height of 27, which is equal to 56,700. So that would be the total volume of the tank, which means if we knew the original volume with no fish was 52,500, and with the fish it's 56,700, to find the volume of the fish, you would do 56,700 minus 52,500, which is equal to 4,200 centimeters cubed. That's one option. You can do it that way. Take the original volume, subtract it from the volume with the fish in it. The other option is to do, let me make an or statement here. The other option is to do the volume of just this little rectangular prism. So you've got this really small one here where the water is. So you've got 60, 35, and 2. So I can draw it here, maybe. So this really small rectangular prism, because that's how the water changed when you put the fish in. So that would be the equivalent of how much the volume of the fish once you dropped it in. So that this little small part here is what we're talking about. So this is 2. 60 and 35 never changed, so this is still 60, this is still 35. So if you do that volume, still length times width times height, so you get 60 times 35 times 2, and that also gives you 4,200. So either way, you get 4,200 centimeters cubed for the volume of the fish. So there's a couple ways that you can actually do that one. For your next problem, you have, suppose students are covering the can below for an art project, how much paper is needed? So this can, it's supposed to be a can, it's a cylinder. So if you're covering, that's what I was talking about, that's when you're talking about surface area. How much it'll hold is volume. If you're covering something, you're talking about the surface area. So the surface area formula is 2 pi RH plus 2 pi r squared. So 2 pi RH plus 2 pi r squared. So if you plug in your numbers, then we know the height is 5. We also know the radius is 1.5. So all we have to do is plug in our values. So we have 2 pi times 1.5 times 5 plus 2 pi times 1.5 squared. And if you do all that, you should get 61.3 inches squared. Area is always squared. And then the next question says, how much is needed if they just cover the sides? So if you just cover the sides and not the top and bottom, you're talking about what's called the lateral area because it's on the sides only. If you're talking about the lateral area, there's actually formulas. It's L is equal to 2 pi RH. And the reason is, if you look at this surface area formula, 2 pi r squared is the area of a circle. A cylinder is circles on top and bottom, or left and right, whichever way it's laying. But anyways, in our picture, top and bottom. So basically, if you're not covering the top and bottom, you're just taking off the two circles, the area of those circles. So if we're not covering the top and bottom, all we're talking about is 2 pi RH. So in that case, we do 2 pi times our r is still 1.5 and our h is still 5. So 2 pi times 1.5 times 5 is 47.1. So to do those, if it asks you to take off the top and bottom and only do the sides, then you're talking about the lateral area. So, and I accidentally said area of a circle is 2 pi r squared. Area of a circle is pi r squared, but I meant the 2, there's 2 circles for the cylinder, so that's why there's a 2 in front of it. Misspoke. We're talking about the top and the bottom's 2 circles, so if you're only talking about the sides, you take away those 2 circles. So that's why we take that off, just for the lateral area. For number 3 here, you have the Luxor Hotel in Las Vegas, Nevada is shaped like a gigantic black glass pyramid. The base of the pyramid is a square with edges 646 feet long. The hotel is 350 feet tall. Find the area of the glass on the Luxor. So if you're doing the area of just the glass, the base does not have the glass. So if you look up the surface area of a pyramid, you will see that it's 1/2, and it uses the notation, most things use the notation P, L, plus B. And what that stands for, the B is the base, the area of the base. I'm trying to think of what P means. It has left me. Because I think there's another formula that you also see for a square pyramid. P is the perimeter of the base, and L is the slant height. I knew the L, couldn't think of P for some reason. For this one, if we're talking about the area of the glass, the base does not have the glass. So we're only talking about the sides of the pyramid. So again, you're talking about the lateral area. So we're not going to worry about the B since we're not talking about the base. So we are talking about L is equal to 1/2 PL because we're taking off the base again. So what we need to know is the perimeter of the base. Well, square 646 on all 4 sides, so 4 times 646 is the perimeter of the base. The L is the slant height, so that is what you have to calculate. So the slant height, it's 350 feet tall, so that's this height by dropping the perpendicular down. The slant height is over here on a triangle. If you go from the top here down to the base of the triangle, what is that? It still forms this right angle. And so you got to go back to right triangles and do like we did before. I think we calculated one of these before, sort of similar, where you use Pythagorean theorem, a squared plus b squared equals c squared. So the slant height, by definition, splits this in half. It hits it at its midpoint. So you would have I didn't actually half it. I just did it. I just did 1/2 of 646 when I wrote it down. So if this splits this in half, each side's 323. So to find L, then we have to use the right triangle here. Mine doesn't add up. I just can't draw. Wish I could draw better. Because it's supposed to be that these two might line up, but let me just do it this way. I should have drawn it better. You're supposed to get a right triangle like this. If you look up square pyramids and slant height, it'll give you a diagram that actually looks appropriate. I'm sorry, I can't draw to scale, so let's ignore this. I should have stopped when I dropped the height down. I should have stopped down to here. Yeah, look up, just Google square pyramids and slant height, and then you'll actually see a diagram that looks not so bad. But anyways, to find the L, you're still going to use the Pythagorean theorem. So L is the hypotenuse, so we would have 350 here, and then 323 would be here, because it's a square, it cuts it in half, and then L is our hypotenuse. So we would have L squared is equal to 350 squared plus 323, the half of 646 squared. So it is equal to, L squared is equal to 2,226, or 226,000. I'm struggling today. 829. Clearly have not had enough caffeine or something. And take the square root of both sides. We get L is, if you take the square root of that, you should get something like 476.3 feet. So L is 476.3 feet. So what we are going to do to find the lateral area, we're going to do 1/2 times the perimeter of the base, which we said it's a square, so you just do 646 plus 646 4 times, or 4 times 646, which either way you want to think about it, times our L, which we found to be 476.3 approximately, which is close enough. And that gives you 615,000 379.6 feet squared, sorry, for area. And if you want, you can round up, if you don't want to take the decimal, 615,380 feet squared would be how much glass is on the Luxor, which is a lot of glass. Would probably be a pretty impressive hotel to see if you're ever in Las Vegas. And like I said, to see an actual diagram that looks correct with the slant height and such, if you'll just Google surface area of a pyramid, and it'll show you a diagram that's much better than mine. So for the last one, you have how much air can a basketball hold if the radius is 4.7 inches. So a basketball is a sphere. So here's our sphere-shaped basketball, sort of. Radius is 4.7 inches. We're talking about how much a basketball can hold. So again, if you're talking about how much something can hold, it's volume. So the volume formula for a sphere is 4/3 power cubed. So we would plug in our numbers. So 4/3 pi, we know r is 4.7. And if it gave you the diameter, you would just divide it in half to get the radius. And if you calculate that, you should get 434.9. And this was in inches, so inches cubed would be your units. So that's how much air the basketball can hold. So for your homework for this, the homework's similar to the examples, so you can follow those along. And if you have any questions, please send me a message.